Hello guys, with the name of God, Ram Ram. First of all, we congratulate our student for cracking off-campus offer from Amazon. You guys can check out my special video. Can check out the special video with my student. Also, congratulations to one more student for cracking off-campus offer from Amazon in February. Like we have 10-15 selections in Amazon in this year only in our daily life training and personalized one-to-one mentoring plus a referral based program. If you guys want to check out the best DSA OECP program in the country, you can check out the link given here. Now today we have to discuss Codechef starters 179, right? Codechef starters 179. Okay. So slowly, let's start discussing all the problems. Well, this was the first problem of Division 2. So the first problem of Division 2 is lost in the fest, rating 872. So guys, this is a big problem, but I will try to tell you in short what they are trying to say. They are saying that you are at the last index of the array. How many people you need to remove in front of you so you can see the show which is going on in the front of the array. Height array tells the height of each person at index I, and our height is h of n. So like if I try to show you, nothing difficult, right? It's totally easy. This is the array, right? Let's say this is 5, okay? This is 8, this is 10, this is 11, okay? This is index 1, this is index 2, this is index 3, this is index 4, this is index 5, and this is index 6, okay? A show is going on here. Can you are this guy, this is me. Can we watch this show, guys? Can we watch this show? No, we cannot watch this show. Why? Because our height is 5. But here there is a guy bigger than us standing here. Oh, such a bad thing. There are bigger guys standing. So my eyes are here. If I try to see, and the show is going on here, this is the show. I cannot watch this show because a guy bigger than me is standing. This 8 is blocking my eyesight. So I need to remove the 8th guy. So that's the question, that how many guys do you need to remove? So guys, if you try to visualize, can you see how many guys you have to remove? You will have to remove the 8th guy, right? From your path. So if you swap with the 8th guy, you will go one step ahead and 8 will be beyond you. But guys, still you will not be able to watch the show. Why? Because now there is a 10. You will then try to remove the 10th guy also. Still it will not work because there is a 11 here. So now you will try to remove the 11th guy, right? Guys, after removing the 11th guy, how are the things looking like? Things now look like this. This is the guy with height 1, this is the guy with height 2, and our guy has removed 5. Rest all have went behind. So this is our guy with height 5. Now guys, I can watch this show. Why? Because all the guys ahead of me are having the height strictly less than me. Okay. So guys, I hope you understood that you can watch the show only if the guys ahead of you, all of them should have their value less than your value. Okay. Okay. Because we have to cover all the solution of all the problems, I will try to go through very quickly. I will explain everything only one time. If you are not able to understand, you can ask in the comments, or what you can do is you can replay the part which you want to understand. So guys, my theory says that if I am at index n, I can watch this show if and only if whatever is the maximum guy in this place, na, whatever is the maximum guy in this place, whatever is the maximum of numbers from 1 to n minus 1, that should be strictly less than h of n. This is my h array, and h of n, this is the nth index 5. The maximum of them should be strictly less than 5. Then only 5 can go and watch the show, right? Right? But here the maximum is not less than 5. So it is not possible. It means you need to kill someone. So what will you do next time? If this condition does not work, what will you do? You will kill the n minus 1 guy. So this is not working. So I kill this. Now what will be the condition? The max of this. Max of this should be strictly less than my 5. Is that true? No. Max of this is 11, which is not strictly than 5. So I will go one step more behind in my for loop, and now I will kill this guy. What is the max of this? Max of this is 11. Is 11 less than 5? No, sir. It means I need to kill this guy also. Now, is max of these two elements, max of 1 comma 2, is this less than 5? Yes. It means I can watch the show. How many people I had to kill? I had to kill 3 people, sir. So 3 is generally the answer. How many people you had to kill? You had to kill 3 people. So they are not asking you exactly how many people to kill. They are asking you that after killing all these people, which index will you reach? So the total number of elements minus 3 minus 1 should be the answer. That's what I think. Like that's what they are asking, right? No, no, they are asking you how many people you will have to kill, or how many swaps. See, killing one person is equal to one swap. Why? Because here there was 8, here was 5. You are killing 8, right? Killing 8 means 5 comes here, 8 goes at the back. So guys, that's it. So there is a O of n square solution which you understand, right? For each index I, what will you do? You will have to find the maximum in this range. You will have to travel from 1 to I minus 1 for each index I. For each index I, you assume that all these have been killed. Now check. First you find the maximum, check. Is this less than 5? Then this is the only answer. The number of people killed you can track here. That's the answer. Like this you have to do for each index. So for each index you will have to travel from 1 to I minus 1. 1 to I minus 1 can take in the worst case n steps, right? If I equal to n. So for each index I you have to do O of n. So it is total O of n square solution. How you can optimize it? You can make a prefix maximum array. You can make a prefix maximum array which stores the maximum of all the numbers till index I. What is the maximum of this much part 1? What is the maximum of this much part 2? What is the maximum of this much part 11? What is the maximum of this much part 11? What is the maximum of this much part 11? What is the maximum of this much part? Though this is not dated 11. So now if I decide that okay, I want to kill this is my index I, right? I want to kill this. I want to know the maximum in this much part, which is nothing but 1, 2, 3, 4. It is nothing but P of 4. So just need to check if P of 4 is strictly less than 5 or not. P4 is nothing but I minus 1. So at index I, you just need to check is P of I minus 1 less than this. If yes, you can kill. So the problem is totally solved. Okay. Height array tells us the height of each person at index I. Our height is h of n. You can watch the show at nth index if and only if max of this value is less than h of n. If this does not work out, you can kill the nth guy and you can say that you can watch the show if you are at n minus 1th index. If you come at n minus 1th index, only if uh, by removing the n minus 1 guy, if max of 1 to n minus 2 is less than h by. Like this you will try until the situation works out itself. So if I try to show you the code, well, you can see it here. Nothing else much happening. First you create this prefix array. Now you travel from the end. You know your height is always h of n, right? So if this is greater than p of I, means p of I means what? Please know that P of I is nothing but maximum of all the elements from index 1 to I. So P of I is nothing but maximum of all the elements from 1 to I. If this is true, your job is done. Else you need to kill this guy, answer plus plus, and that's it guys, that's it, problem solved. I did more than the Div2 third and fourth problem. Why? You will understand why. The nice thing about this problem is that this is a really very interesting problem. Okay, it makes sure a beginner uses their complete mind. So they are saying that we have given you two arrays, array A and array B. You need to make sure that array A is converted to array B in exactly k moves. Okay, but you can only convert them by using a trick. Okay, so you have a dialer from 1 to 9. So let's say this is a array, this is 2, this is 4. Okay, let's say this is 4, and let's say this is 8. Okay, and k equal to 6. So they are saying, can you convert array A to array B in 6 moves? Can you do this? So you are given a dialer like this. See, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 8 to 9, and 9 to 1. Okay, clear? We are given a dialer like this: 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5, 6, 7, 8, 9, 10. Okay, so not 10, let's 1. Okay, so guys, if you want to come from 2 to 4, how many moves it will take? 2 moves, which is nothing but 4 minus 2. So you will just calculate the difference now, that okay, to become from 2 to 4, it will take me 2 moves. To go from 4 to 8, to go from 4 to 8, 4, 5, 6, 7, 8. So 8 minus 4, 4. So it will take 4 moves to go from 4 to 8. So guys, 2 plus 4 is nothing but 6. So yes, it is exactly possible to reach this thing in 6 moves. Okay. But guys, the trick is that even if the k is bigger, na, you can still do something to get the job done. Even if the k is bigger, you can still do something to get the job done, because there are two ways. Okay, there are always two ways. Okay, let's take the example where your particular a was, let's say, 2 and b was 4. Okay, and k is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So you might think that, sir, from 2 to 4, I need to go. Only two moves are required, which is 4 minus 2, right? For each index, you can calculate the minimum number of moves required, right? Only two moves are required. But, sir, they are telling us to use 10 moves, sir. How to do in 10 moves, sir? See, what is the difference between you have already done two moves, they are asking you to do 10 moves, but your final destination should be 4 only. So what will you do? This is the first move, this is the second move. In the third move, you will just do up and down, up and down, up and down. See, third move, you will go from 4 to 5. Fourth move, you will again go back. Fifth move, you will again go like this. Sixth move, again up. Seventh move down. Eighth move up. Ninth move down. And 10th move again at 4 only. So basically, in two moves, in two moves, you can reach the number 4. But they are telling you to use 10 moves. So 8 extra moves you have to use. So what you will do in these 8 extra moves, this number should be even. I reached 2 to 4 in 2 moves. Now in 8 extra moves, I will just do time pass here. See, because it is even now, I can go back and forth. One time here, second time here, like this. In 8 times I will again reach 4 only. So guys, the thing is that for each index now, you have to calculate the sum of minimum moves. Okay, let's say it was like this. You know that the minimum moves from 2 to 4 is 2, and 2 to 4 is 2. So this is 2 plus 2, which is nothing but what? 4. Okay, 2 plus 2, which is nothing but 4. Okay, 2 plus 2, which is nothing but 4. Okay, but you want to make 10 moves, so what will you do? You want to make 10 moves. Okay, but in total you only did required 4 moves, right? Because one guy took 2 moves to come from here to here, and one more guy took 2 moves to come from here to here. Now any of that guy, you know that you have to make 6 extra moves, right? In 4 moves the whole array is getting solved. You want to make 6 extra moves, and this number is even. So take any one index, do 6 time extra operation here. One time here, 2, 3, 4, 5, 6. Because it is even, you will reach 4 again. So that's the solution, guys. And this problem, lovely problem, gets solved. Okay. So You will first find for each index the minimum moves to convert from A to B. Find the sum of all of them. If the sum is less than equal to K, if the sum is equal to K, the answer is yes. But if it is less than equal to K, check the difference. If the difference is even, you can do some time pass at the end of some move and make sure you stay at K only. But if the difference is no odd, we need to do something else. And guys, if the sum is greater than K, then you can do nothing. Nah? For example, in this case, if K was 0, then what can you do? Or if K is 1, can you do anything? No, minimum 2 moves are required. So if the number of moves, minimum sum is greater than K, the answer is never possible. Okay. Now guys, what if the difference between, let's say, our moves are less than equal to K, okay, but the difference is odd, then how will we solve the problem? K equal to 9. Now how will we solve the problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, like this, okay? Like this, the things are going on for you people. Now what will you do? Now the thing is that guys, the thing is that 2 to 4, you will say that sir, the distance is minimum distance is 2 sir. Okay, after 2 moves you need to do something to reach 9 moves. You need to do 7 extra moves. How will you do 7 extra moves, bro? Not possible to do 7 extra moves. Why? First move you come here, second move there, third here, fourth there, fifth here, sixth there. In odd one you will come at position number 5. So when the extra moves are odd, you are screwed. Now what will you do? Instead of going from 2 to 4, now you will travel from 2 to 4 using other path. Can you see this other path? What is the size of this other path? It is nothing but 9 minus 2. So there are always two options. Either you can make 2 moves or you can make 9 minus 2 moves, which is what? 7. So guys, I have two options. Either I can go in 2 moves from 2 to 4, or I can go from 2 to 4 in these 7 moves. And the nice thing is that the parity will always be different. Why? This number is 2, which is even. If it is even, then 9 minus 2 will be odd only. Let's say this was a odd number. Then 9 minus 3 will be even. So odd becomes even becomes odd. So guys, earlier, what was happening? When we choose 2 as the answer, the extra amount was coming as odd, which was not good. But what if I take the second option? What if I make this one option, to go from 2 to 4 is 2, another is 7. So let's take 7 one. Then what will happen? 7 moves done plus something equal to 9. This is 2, which is even. So you can do even time pass. You go reach here in 7 moves. Now 8 move here, 9th move here. Because the difference is now even. 9 minus 7 is 2. So guys, the problem is solved. You might be given many A's and many B's, but you can always solve the question. Let's say this is your A and this is, let's say, your B, okay? Let's say it's something like that. So feel it deeply, See, the minimum difference here is what? 2. And the other difference is what? 7. Minimum difference here is what? 4, right? And the other difference is what? 9 minus 4, 5, okay? This thing you can observe. You also feel it. I also feel it, okay? You also feel it. I also feel it, okay? So for k equal to 8, you can solve this problem, right? You will find the sum of minimum moves. What is the sum of minimum moves, guys? Here the minimum move is 2. Here the minimum move is 4, which is what? 6. And difference of 8 and 6 is even. You can just do time pass, right? At the end when you reach. So it is possible to solve for k equal to 8. But guys, what if k was given to you as 7? Would you just sit and cry? What if k was 7? The minimum moves here is 2. Minimum moves here is 4, which is what? 6. Now the difference of 7 and 6 is coming as 1. Difference of 7 and 6 is coming as 1. Where can you make one extra move so that nothing gets affected? You cannot do this. So at one of the places you have to make a different choice. See, here also you took 2, right? Here also you selected this 2. Here also you selected this 4. But the sum came as even. And now the difference with this is coming as odd, which is not good. So you need to change one number. Which number will you change? You have two options, guys. You have two options. See, one, you have selected here 2, you have selected here 4. What is their sum? Their sum is even. You want their sum to be odd. And because the numbers are nothing but the pairs of the number and 9 minus difference, if this is even, this is odd. If this is even, this is odd. So even if you replace any one number by another option, it will the sum will become odd, a problem will be solved. So there are two options. Instead of 2 comma 4, you can either use here, instead of 2 you can use 7. So either it can be 7 comma 4, or you can do the, you can keep 2 here, and here you can use 2 comma 5. Which one will you select? 7 plus 4 is 11, which is bigger than k equal to 7, but 2 plus 5 is working. So the solution is that if the minimum moves are not working now, you just need to change one move. But which one move you will change? The one which is increasing your number of moves by the smallest number. If for 2 comma 4, if you replace it by 7 comma 4, earlier the moves were 6, but now the moves are 11. But if you replace 2 comma 4 by 2 comma 5, earlier the moves were 6, but now they are 7. Can you see why this is the best choice? Because here the increase is happening only by 1, and here the increase is a lot. Why are we going towards the smallest increase? Because if the minimum number of moves are increasing by a small number, there are chances that it will remain less than equal to k. Why? Because if minimum number of moves increase a lot, they will become greater than k, and the answer will become no. So if I change any one particular index now, the minimum number of moves have highest chance to be less than equal to k, and the parity is also changing. Earlier the minimum number of moves were even. By changing any one index, it will become odd sum. Or if earlier it was odd, it will become even sum. That's why earlier the difference between k and this was odd, now it will become even. So such a tricky nice problem, right? So if I try to show you the code and implementation, guys, you will fall in love with this, by the way. So what is happening? For each place you calculate the difference, and the other difference is 9 minus difference, right? But guys, you need to know the difference between these two moves also, because right, and you take minimum of all of them, because this is the minimum increase possible in case nothing works out. So guys, the same operations, if your minimum moves is strictly greater than k, then nothing can be done, because you selected everything minimum, then also not working. Now the minimum moves can only increase, man, so not possible. If minimum moves is less than equal to k, just check the difference. If the difference between them is even, you can do some extra time pass moves and get the job done. But if the difference is not even, what will you do? Minimum move parity you need to change, guys. If the difference between min move and k is not even, it means one of them is odd and another is even, so you need to change their parity. So I will try to increase minimum moves by the smallest number possible, which is this p. Every time diff and 9 minus diff are possible, so every time if I change from diff to 9 minus diff, it will be x1 minus y1 difference in the total sum, right? So p, I try to add that thing. If after adding that our moves become greater than k, we can do nothing. But if it is less than k, it is sure. This is a very interesting problem of division 2. It should be at number 4, but it was at number 3. We will not go into those reasons for now, but this is a really lovely problem. So guys, we are given an array, and there is a small property of that array. The small property of that array, first of all, we start and do everything with the name of God Ram Ram in our lovely program. So guys, there is a small, nice, good, lovely quality of that array. Okay. So what is the quality of that array is that all the elements have adjacent difference of 1. So see, if the first number is 3, then the next number will be 4, 5, then 3, then not 3, like then 5, then 4, then 3. Like, kudos to the problem setter. then 1, then again like 2, then 3, then 4. Like this your array will be. Can you see the adjacent difference between any two numbers is just a single one? Adjacent difference between any two numbers is just a single one. Adjacent difference between any two numbers is just a single one. Adjacent difference between any two numbers is nothing but a single one, right? One, 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 one. So, guys, the main observation is that your array will just be nothing but a mountain which is strictly increasing and strictly decreasing all the times. If you visualize this lovely array, it will always look like this. Let's say this is the value at index 1. At index 2, it will increase by 1. Index 3, it will increase by 1. Then, if it can decrease by 1, but it should decrease or increase by 1. Then, like this. See, can you see these mountains can go any way they want to go? So guys, like this it will be. Can you see? This is the increasing part. This is the decreasing part. This is the increasing part. This is the decreasing part. This is the increasing part. This is the decreasing part. This is the increasing part, and this is the decreasing part. So the thing is that we have to find in this increasing decreasing array where each adjacent element has a difference of 1. How many good pairs are there? What is the definition of a good pair? Let's discuss that first. What is the definition of a good pair? Okay. What is the definition of a good pair? I comma j is a good pair if I comma j is a good pair if both of them can reach index k. So guys, you should just be able to travel in left hand side or right hand side, and you should be able to reach a different index k. Guys, what is the rule of traveling? You can travel from I to k only if all the numbers from I to k are distinct. Guys, this thing you should know, okay? Similarly, you can travel from j to k only if all the numbers from j to k are distinct. Only if all the numbers from j to k are all distinct, okay? You can travel from I to k if all the numbers from I to k are distinct, and you can travel from j to k if all the numbers from j to k are distinct. These things are clear to you and you are very happy about it, okay? So let me tell you which are the good pairs. Like initially when you read the question you feel a little bit pressure. Don't feel the pressure, guys. Just calm down, guys. Kumar Kisar is with you. So 3 4 5 4 3. 3 4 5 4 3. This is 3, this is 4, this is 5, this is 4, and this is 3. So guys, in this lovely array given to us, there are many good pairs. Let's discuss any one good pair. Okay, let's discuss any one good pair. So someone can say that index 1, 2, 3, 4, 5. Index 1 comma 5 is good. Why? Like this, you have to count all the good pairs, okay? Why one? Obviously, you cannot do off n squared solution. If you're watching video till here, you are intermediate in CP. So, like checking all pairs is not efficient, right? But still, how will you know if 1 comma 5 is good? This is 1, right? This is index 1, this is index 5. They are good pairs. They can make friendship 5 because both this is I, this is J. I comma J is a valid pair or a good friendship. Why? Because they can reach K equal to 3. They can reach this index by traveling. You see, I can travel from here to here. And J can also travel to K. You can see this, right? 3, 4, 5. And why is this travel valid? Because all the numbers from I to K. See guys, I to k you can only travel if the numbers from I to k are distinct, and they are actually distinct in this particular case, you can see. And here also from I to k all the numbers you're traveling are distinct. So yes, it can be solved. But guys, the if you try to solve like this, it will take n cube time, right? N square time it will take to check all the pairs I comma j. And if you have selected I and if you have selected j, you will again have to travel this whole array to find a point such that from that point you can travel here also and you can travel here also. So you will again iterate through all the points. Let's see if you fix a particular point k. Then from k you will again have to travel to I and j, which will again take O of n time. So it can take n raised to 4 time. And if you optimize a little bit smartly, you can even get it to n cube, which is both are not good. N is 2 into 10 raised to 5. You need O of n solution. Okay. So guys, we use the standard trick which is taught in our 850 hour DSA plus OA plus EP course for hashing problems. To solve this problem now, we fix the index j. We travel the index like j from 1 till n, and we will try to find all the valid pairs from 1 to I minus 1. Okay, for each index j, for each index j, for each index j, find the valid pair I from 1 to I minus 1. So guys, if we are able to do this for all the j's and sum it up, we will be having our answer, right? So guys, you will fix a index j. You have to find out how many good relationships are possible with the numbers ahead of j. Okay, so let's do the math. Let's say guys, you are at index j and this value is 3. Okay, and these are the guys above you. Okay, okay, and this is your index j. Let's say this is index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So guys, from for this index for j equal to 11, let's say I'm at j equal to 11. I need to know how many good I are there. How many good I are there from the range 1 to 10. So guys, how many i's are good? Only those i's are good which can directly reach j. Guys, can you tell me which of the I can directly reach j in this range? See, this this number 4, right? This number is 4. So this guy can directly reach j. Yes. 4 can reach 3 because 4 and 3 is distinct. And 5, 4, 3 is also distinct. It can also reach. 6, 5, 4 is 3 is also distinct. It can also reach. I am saying that 8, comma 11 is a valid pair. 9, comma 11 is a valid pair. 10, comma 11 is a valid pair. That's it. Why? Why are only these three people valid, guys? Because 4 comma, see, when you go from 10 to 11 there is only 4 and 3 in the journey which are distinct. When you go from 9 to 11, 5, 4, 3 are in the journey which are distinct. When you go from 8 to 11, 6, 5, 4, 3 is there. But if you, my lovely student, if you try to go from 7 to 11, you will fail. Why? 5, 6, 5, 5 coming 2 times. Nah. All the numbers should be distinct in your journey. So guys, what do you realize? That why the you just have to know that how many numbers continuously from here can reach here. If 3 numbers can reach here, means 3 good pairs are there. And the problem is solved. For each j, you can find how many continuous people on the left hand side can reach that particular j. Okay, so that's the issue. Okay, that's the issue. So how will you know that? And guys, why are they good pairs? Because see, why 8 comma 11 is a good pair? Because this guy can reach this guy, right? Right? And this guy is already standing here only. So this is your I, this is your J. We are doing a shortcut trick. Here I is 8, here J is 11, and both of them are trying to reach K equal to 11. So J does not have to travel to K because J is equal to K. Only I has to travel like this. So this is the nice, brilliant solution, guys. That uh, these are the pairs ending at index J which are actually good. They are actually good, guys. They are actually good. Okay, but guys, how will you know which of them can directly reach J? If someone can directly reach J, means I comma J is good. Why? Because I can reach J, and you declare your K as J only, so K and J is same, so K can reach J. Done, 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 done. Now, how will you know how many guys on this left range can reach you? It is nothing but the length of the longest increasing or decreasing array ending at index J. Why? If I try to make the diagram for you, can you see this diagram? You can see that J was 3. You can see that this was 4. You can see that this was 5. You can see that this was 6. And this was again 5, and like this. So this is your J, right? What is the length of the longest increasing array ending at index J? The length of longest increasing array is 4. So 4 minus 1, current number 3. There are 3 elements which can reach. Why the longest increasing array? Because here it is not anymore increasing. If you go ahead and you try to include this number, you know you will fail. Why? Because if you go from 5 to 6, the peak, you have to come down for sure, and the 5 will be repeated. And it will not be allowed. So only the longest increasing array, the size of the longest increasing array at index J tells you how many elements can come to J, and they will make the good pairs with J. So guys, how to find the longest increasing subarray at any particular index J using pre-computation? You can just use prefix suffix method, okay? And similarly, longest decreasing array is also possible at index J. They can also reach J easily. So just find, guys, I hope you understand that only the elements of the longest in decreasing array ending at J, they can only reach J, because they all will be distinct. Once the longest decreasing array is broken here, then you know that if you go from here to here, 5 will repeat for sure. Okay. So guys, for each particular index now, I will make a IN array, and I will make a DC array. IN of I will tell me length of longest increasing array ending at index I. And DC of I will tell me the length of longest decreasing array ending at index I. And this will just solve the problem, guys. So guys, for this particular problem, can you tell me what will be IN, like the longest increasing array ending at index 11? What it will be? The longest increasing array ending at index 11 is nothing but of size 4, right? So IN of 11 is what? 4. What is the longest decreasing array ending at 11? There is no decreasing array, only one element you can. The DC of 11 is what? 1. So which is the biggest of them? 4 is the biggest of them. So minus 1 you do it, you know 3 guys are there. So answer equal to answer plus 3. So guys, you can see in the implementation also, lovely people. For each index, you just try to find out how many people can reach you, which is nothing but the length of the longest increasing or decreasing array, right? So guys, increasing array, decreasing array, you're traveling, right? At first index, increasing I and DCI both are 1. If the previous element is smaller than the current element, then the IN of I will increase by 1, and DC of I will become 1, because it's in increasing fashion, so there is nothing decreasing and ending at index I. Similarly, with the opposite, vice versa, DCI you can update, okay? Reach of I tells you How many guys, reach of I tells you how many guys from range 1 to I minus 1 can reach index I, which is nothing but maximum of increasing array or decreasing array ending at index I minus 1. So you must be saying, sir, that the sum of the reach of I of all is the answer. No, beta, there is one more trick. You might be thinking that for index j equal to 11, you might be thinking that in of j minus 1 is the answer. In of j is what? Increasing of 11, 4 minus 1, 3 is the answer. You are thinking that only 3 good pairs are there. Which are those 3 good pairs? 8, comma 11, 9, comma 11, 10, comma 11. But 7, comma 11 is also a good pair. Why? 7, comma 11. See, 7 cannot directly reach 11, but both of them can reach 8. 7 can reach 8. 11 can also reach 8. So, this biggest observation solves the freaking problem. 7 can reach 8. 11 can also reach 8. So, guys, now you know the max boundary of this, right? You know the max boundary of the longest increasing array is this. Now we just need to know how many guys can directly reach 6. How many guys can directly reach 8 on the left hand side? So you can say that, sir, 7 can reach 8, index 6 can reach 8, index 5 can reach 8, sir, index 4 can reach 8, sir, index 3 can reach 8, but can index 2 reach 8? No, 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 no. Why? Because for index 8, if you try to make the longest increasing decreasing array, it is still here only, then the bond is broken. So I mean to say that 8 can be reached by 3, 4, 5, 6, 7. And you also know that 8 can be reached by 11 or 11 can be reached by 8. So 8 is acting as the center point now. So because 3 can reach 8, 4 can reach 8, 5 can reach 8, 6 can reach 8, 7 can reach 8, it means 3 comma 11 is also good. 4 comma 11 is also good. 5 comma 11 is also good. 6 comma 11 is also good. 7 comma 11 is also good. So the final answer will be these three elements which can directly reach 11. So the final answer for j equal to 11 is the number of elements which can reach 11 plus the number of elements which can reach 8. How many elements can reach 11? 3 elements. 1, 2, 3. This is the last point possible. Now whoever can reach 8 can reach. Whoever can reach 8 is also a good pair with j equal to 11 because 11 itself can reach 8. Right? That's it. So now we are considering this as our k. Earlier we were counting the pairs I comma j where this was considered as k. Now this is considered as k. Now someone might ask, sir, why did you only consider 11 and 8 for k? Why did you never consider any other element for k when j is equal to 11? Other element can never become k. Why? Let's say you try to make like usually it will not become. Let's say you try to make this. Okay, obviously you can go from 11 to 9, but these numbers can never reach this. Why? Because 5 will get repeated if they try to reach here. So k can only be 8 or it can be 11. It cannot be anything from here. Now if you try to make k something outside of this, let's say you try to say that, sir, I will try to make this value as k. Okay, anyways you can never reach here because the repetition is happening. This is k, right? This is k. So this guy might reach here, but this can never reach here because the repetition of 5, 6, 5 will come. So k can only be this guy and this guy. So the answer is reach of current guy, reach of 11 plus see how many guys you need to go back and reach of this. Such a brilliant problem. When I realized the solution, I was like on cloud 9. Like coding is really interesting if you're not taking any external stress in life. So guys, this is it. You can see first you calculate how many guys are good pairs with the index p is nothing but reach of p plus reach of id, where id is nothing but the current index minus reach of p. You know, if there are 3 guys, then you can go 3 back. So that's it, problem solved. Hopefully you guys enjoyed it. So, hello guys, with the name of God Ram Ram. Always do everything with the name of God Ram Ram, and then no one will be able to stop you from anything. So, now guys, we have to solve this problem which is station allocation. So, they are saying that we are giving you an array C, okay, and for each x comma y you need to do something. So, they are saying that we are giving you an array C, okay. So, let's say you have an array C like this, right? You have some set of elements C1, C2, C3, like this. You have elements like this, guys. You have elements like this. Till Cn, you have elements like these. Okay? Everything is going great. They are saying that, hey, bro, we are giving you x, comma y. They are saying, tell me the minimum operations to satisfy x, comma y. This is a very nice greedy problem. So guys, what do we need to satisfy in x and y? They are saying that what you can do is, when x comma y and c array is given to you, right? Satisfy. The condition is that you can read here also that x should be strictly less than equal to c of I. Okay. So you need to pick a number. Pick any index I such that what should happen is that x should be less than equal to c of I, and then y, or let's, like, you have to pick any c of I such that it is greater than equal to x, and y should be greater than equal to sum of remaining elements. So guys, you know which are the remaining elements: c1 plus c2 plus ci minus 1 plus ci plus 1. C of I has been used, so that will not be used again, like this, till c of n. So guys, these two conditions should be satisfied. That's all they are asking us. And you can increase any number in C array by any number of, you can increase any number in C array by 1 in one cost. Tell minimum cost tell minimum cost of final array C. Tell the minimum cost to satisfy both the conditions. So guys, that's it, and the problem is solved. So let's do some checking, right? Let's say I'm giving you this C array, okay? 1, 2, 3, 4, 5, okay? Let's say x is equal to 3, and let's say y is equal to 2, okay? So guys, you want to find out the guy here which is greater than equal to 3. You will say, sir, this is also valid. Sir, this is also valid. Sir, this is also valid. Which one to select? We don't know which one should we select for the optimal answer. We just want to select a guy which is greater than equal to 3 for satisfying the x condition. So let's select 3 only. For now, let's select 3 only. Let's make this guy as our index I, and let's select this guy only. Then what will happen, my lovely students? Ha ha ha. Then what is gonna happen is that you have selected this, right? So first condition is satisfied, right? C of I greater than equal to x has been satisfied. X is 3 and C of I is also 3. Now guys, what is the sum of the remaining elements? 1 plus 2 plus 4 plus 5 should be greater than equal to y. What is y? Y is given as 2. So guys, y is given as 2, right? This is already greater than equal to 2. So no extra operations you have to do. You have to do 0 operations. But guys, what if your y was 20? Then what would you do? What if the query was x equal to 3 and y equal to 20? What if y equal to 20 was given? Now what would you do? You will say that, sir, first condition is still satisfied, right? X greater than equal to c of I. Because I am choosing 3 as the CI. Now the remaining elements are what? 1 plus 2 plus 4 plus 5. This thing should be greater than equal to y. 20. Is this? No. Why? Because 5 plus 4, 9, 10, 11, 12, right? This is 12. You want 12 to be greater than equal to 20. This can only happen if you do 12 plus 8. So answer is 8. You need to do minimum 8 operations. Okay. So guys, you must be feeling that, sir, this is such a easy question, right? For any x comma y, what can you do? Like, this is the array given to you. Okay. This is the x given to you. This is the y given to you. First, what you will do? Find any element in this array which is greater than equal to x. But there are multiple choices. Should I select 3, sir? Or should I select 4, sir? Or should I select 5, sir? My proof says that you should always select the smallest number, smallest c of I, which is greater than equal to x. Why should you not select 4 or 5? I will show that visually to you. Let's say I select my x as 3. So it is like, sorry, x is already given, right? 3 comma, like x equal to 3 and y equal to 20, right? So I select this as my ci as 3. It is greater than equal to x, the condition satisfied. Now what is the remaining elements? 1 plus 2 plus 4 plus 5. They should be greater than equal to y, which is not possible. So you will do plus 8 here. But you can say, na, sir, what if I selected 4 in the first? Then what would happen? You selected C of I as 4. So obviously this is greater than equal to x3, right? But now the remaining element sum becomes smaller. Remaining element is now what? Earlier it was 1, 2, 4, 5. Now it is not 1 plus 2 plus 4 plus 5. 4 has been used already. Instead of 4, now there is 3 left because you made the fourth guy as the ith guy. So 1 plus 2 plus 3 plus 5 needs to be greater than equal to y. You need to add 9 to this to achieve the answer. But if you selected 3 as your smaller number, then the amount of effort needed to make it greater than equal to y would be smaller. So guys, the first case is clear, right? What will you do? What is the general algorithm? No matter what x and y I give you, you travel this array and find a guy which is greater than equal to x. You will say, sir, 3 is also greater than equal to x, 4 is also greater than equal to x, 5 is also greater than equal to x. Which one should I select? Select the smallest of them. Because if you select the smallest of them, the remaining sum 1 plus 2 plus 4 plus 5 will be very big. If it is big, there are chances that it will be greater than equal to y. Even if it is not greater than equal to y, minimum number of operations will be required to make it y. Rather than if this sum would be small, then it would take too much operations to make it greater than equal to y. So this algorithm is clear. That's what people implemented and then they got a WA. Because what are we doing to solve this question, guys? This is 80% correct approach, or you can say 50% correct approach. That's how the people were thinking in the exam. They are saying that find some c of I which is greater than equal to x, and then the remaining sum should be greater than equal to y. So people only thought about this ci, and this ci. But guys, what about the other ci? 1 and 2. You can select this also as c of I, na? So people will be laughing. Why will you, like, let's say c of I equal to 2 you have selected. Now what will happen? Now what will happen? This is not valid. See, c of I2, you need me to make it greater than equal to x. X is 3. So what will you do? One operation you need to do, right? 2 plus 1 you need to do. So plus 1 operation done in the first condition. Now what are the remaining elements? 1 plus 3 plus 4 plus 5 needs to be greater than equal to 20. What is this value? 4 plus 5 is 9. 9 plus 3 12 plus 1 13. So 13 you have to make 27 operations need to do. 7 here and plus 1 here. Total 8 operations, guys. Can you see? In the starting, when you were just trying to select greater than equal to x, you got 8 as the answer. But even if you select the starting element as less than x and later on you do the operations, answer can still come 8 or even better than 8. So how will you decide? The question boils down to how will you decide? The greedy strategy says how will you decide which CI to pick up? I give you any x, I give you any y. How will you select which I to pick up? So guys, there are only two options by the way. Analysis will tell you, analysis can lead to paralysis sometimes, okay? So analysis, sorry, not paralysis actually. Which CI to pick up? Which CI to pick up? Which C of I to pick up? So guys, this is also pretty easy. Either you see there will only be two cases. The first case is you try to pick up a CI which is greater than equal to X. First case is you decide any CI to pick from 3 or 4 or 5. Which one to pick if you are only picking the CI which is greater than equal to X? If you are picking any CI which is greater than equal to X, guys, then what is going to happen? Our CI is already greater than equal to X, so we don't need to do any extra operations. The remaining sum will be what? Remaining sum will be S minus CI. So y minus S plus CI you will have to do, right? But you want to decrease this, you know na, if you select for Ci greater than equal to x, 3 4 5 all are valid, but which one should you select? The smallest number you should select, which is greater than equal to x, because if you select bigger numbers, you know na, the operations increases, right? So that's what it is written, that if if you are only considering the numbers Ci which are greater than equal to x, in that case select that element which is greater than equal to x, but its value should be smallest, so that later on when you try to satisfy the y condition, y minus s is constant but the c plus the c of I is variable. This should be minimum na, then only this number of operations will be minimum, and this can be zero also in case this is already satisfied, guys. But now comes the another case. So we have solved the case, when c of I is greater than equal to x. Now let's solve the case when we select a, now the only case pending is what to do when you select, what to do, you know, 3 comma 20, you know, x comma y is given 3 comma 20, huh? What if I select an I such that Ci is less than x? So guys, which are the Ci? First make sure you sort this array of C, huh? So guys, these are the two elements which you can select for Ci less than x. Then you will have to do some operations here, and you will have to do some operations for y also, for the greater than equal to the remaining sum. Now guys, the option comes, should I select 1 or 2? You can feel that you should always select 2. Why? Well, let's say you select a Ci strictly less than x. What is going to happen? It will take x minus Ci operations, right? And then it will take, to satisfy the y condition, it will take y minus s plus c of I. Guys, if you select this, let's say you say Ci equal to 2, you select, okay? So first it will take you what? X minus c of I operations, right? First it will take you x minus c of I operations, right? And then it will take you y minus s plus c of I operations, assuming this is positive. So in that case, what will happen? X is constant, y is constant, s is constant. So minus ci plus ci gets cancelled. If this gets cancelled, if y minus s plus c of I is positive, so you can take any number. You can take 1 also, you can take 2 also, does not matter. But guys, what if what if this quantity comes as negative? If this comes as negative, you ignore this part. If this comes as negative, you consider it as zero. Negative कब होगा? If y is greater than the remaining sum. What is the remaining sum? S minus c of I. In this case, we do zero operations, right? In this case, we do zero operations, right? So if y is greater than or equal to s minus c, it means y minus s plus c of I, y minus s plus c of I is what? Y minus s plus c of I is positive. Okay, this thing is positive. Okay, this thing is positive. And finally, what answer was coming? The answer was coming as x plus y minus s, right? X plus y minus s in general. Okay, so guys, this much you can understand. Okay, so what I'm trying to say now, that forget these things, forget the positive negative for some time. Let's try to make it easy. In general case क्या होने वाला है? ये जो वैल्यू है ना, अच्छा कब लगता है? जब y is greater than equal to total sum minus c of I. This is a good case. This good case, when does that happen, guys? This good case happens when y minus s plus c of I is positive. This is the good case. But every time this good case will not happen. Bad case can also happen. Y can be strictly less than s minus c of I. Okay, this case can also happen, that y is strictly less than s minus c of I. So in this case, this thing can go negative, right? And x minus c of I, x is strictly greater than c of I. So this thing will be positive, right? So positive and negative will help each other. Okay, in this case, and try to neutralize the things. The problem happens when this thing is also positive. When this right hand side value is also positive, na? Then you don't consider its actual value. Why? Because if y greater than or equal to s minus c, this is a good condition. Means y minus s plus c of I is a good condition. If this happens, you can take its answer as zero operation. So if it is positive, you don't take it as positive, you consider it as zero. So only x minus c of I will matter if this comes out to be positive. So you want the x minus c of I to be minimum as possible, and x is greater than c of I. So c of I should be very large. If you subtract large number from x, the difference will be small, right? That's why when you're considering all the numbers c of I strictly less than x, pick up the largest one. Instead of 1 and 2, like 1, 2, there are two options, pick up the 2, the largest one. That's it, guys, and the problem is solved. You can check the brute force code also. Like by increasing this same thing is written here, okay? Taken some help from the editorial as well. Anyways, guys, so the brute force solution is also pretty clear to you people, right? The x and y is given to you in queries. What you can do? First, you find the smallest guy which is greater than or equal to x. Done. Then the total sum minus this guy, the remaining sum. Y minus this, or if negative, then the zero. No operations, right? If y greater than or equal to that done. Then find the guy which is the largest but whose value is ci is less than x. Ci is sorted, huh? Ci is sorted. Please sort the array for clear visualization. I did not say much, but ये C array को हमेशा sorted रखना, ठीक है? So this thing, but now because x is strictly greater than c of I, you need to add the operations of d, and then you know na total sum minus c current. This is the remaining sum. Remaining should be greater than equal to y. If not, take zero. Like if it is not, then you know y minus sum r, or else zero, and this thing. So minimum of both of them. So this is taking O of n time per query, because you are searching, you are traveling this sorted array to find the first number which is greater than or equal to x. You're traveling this sorted array to find the first number which is less than x. But it can be made, optimization is what? Use binary search to find smallest ci greater than equal to x in sorted C array, and similarly find largest C of I less than, strictly less than x. Okay. Okay. So guys, these things are clear to you people, and you guys can now guys, if I open up the implementation, you guys can see it is same as before, but you are doing binary search to find the index of the first ci greater than or equal to x, and binary search to find the first ci less than x. This is a standard binary search problem. How to search a number greater than some other number in an array, sorted array, is standard binary search problem. If you have reached till here, I assume you know that, or else you can search into it. Ram ram. So hello guys, with the name of God, Ram ram. How are you doing? Are you enjoying your life or not? Enjoy it to the fullest. This is the one chance you have got here. So enjoy it fully. Crack Amazon, Google like my students. You can do it. Crack PayPal like my student did it. See how stylish it looks. So guys, you have to solve this problem. Set major prefix. Okay, let's solve it. The easy version. But this easy version is the hardest of all the problems till now. So guys, they are saying that you have to consider each prefix, and you have to tell if that prefix is good or not. Okay. So how many dominating prefixes are there? What is a dominating prefix? I will explain you. Don't worry about that. But please know that you will have to tell that how many dominating prefixes are there. A prefix is dominating if all of its prefix have a majority element, and all of its suffix also have a majority element. So let me try to show you. 11212, 11212, 11212. Now which prefix is good? Is this dominating? I will call it as dominating. Is this dominating? Yes, because only one is coming, right? Yeah. See, when is some particular array having a majority element? What is the size of the array? 5. What is the maximum frequency of a number? 3. Is 3 greater than 5 by 2? If yes, you can say it has a majority element. So you can see, first we are considering this prefix. Does it have a majority element? Yes. So we count it. C equal to C plus 1. Okay. Now, you know that this is a dominating prefix. Is this dominating? Okay, for 1 comma 1, you will make sure that all its prefix are also, good, like having majority element. So is this having a majority element? Yes. Is 1 comma 1 having a majority element? 1. Yes. Now check all its suffix also. Is this having majority element? Yes. Is this having majority element? Yes. So you can say that this prefix was also dominating, and this prefix is also dominating. Now let's try 112. So many people might say, sir, 112 is good. What's the problem, sir? Sir, this has a majority element. This has a majority element. Even this has a majority element. In 112, what is the size? 3. What is the maximum frequency? 2. Is 2 greater than 3 by 2? Yes. You can read the definition of majority element. So all the prefixes are good. But are all the suffixes good? Let's try. Yes, only 2 coming good. But guys, this suffix fails. 1 and 2 fails. Why? Because here this is also coming one time, this is also coming one time. To win, the maximum frequency guy, which is 1 here, maximum frequency guy should be greater than 2 by 2, should be greater than 1. Maximum frequency of 1 comma 1 is 1, is not greater than 1. So 1 comma 2 suffix fails to generate a majority element. Obviously, this is the 112 is correct, but not even a single suffix should fail. This fails, right? That's why 1 comma 1 comma 2 is a failure. Similarly, 1 comma 1 comma 2 comma 1 is also failure. 1 comma 1 comma 2 comma 1 comma 2 is also failure. So hopefully you guys understood these things. Ram ram. Enjoy your life. You will never get it again, beta G. Like you can like now let's try to analyze what should be the solution. Okay, so let's say guys an array is given to you. Okay, the first number is 1, the second number is 2. What will happen? This will be declared as dominating. Guys, this will not be declared as dominating. Why? Because if when 1 and 2 come at the first two positions, na beta G, what happens is that 1 is also coming for one time, 2 is also coming for one time. So in this array 1 comma 2, no one is dominating. So guys, the biggest observation is that the first two numbers should be equal. If this is an array B, this is an array B, B1 should be equal to B2. If they are not equal, if B1 is not equal to B2, none of the none of the prefixes will be dominating except the first prefix, because in that there is only one number. So guys, at the start of the problem only make your head clear that hey bro, yeah, the first two numbers should be equal. If here there is 1, there is 2, now no matter what is there, this will work, but rest all will never work. Why? Because 1 comma 2 is not good now. So this, even if there is a 1 here, this will also be not good, because it will also check, it will check all the prefixes of the past now. The previous prefix is creating issues, man. So the issue will just transfer. So the first two elements need to be 1, guys. The first two elements need to be 1. So that's what I'm writing. If the first two elements are not 1, now see what happens. I am not telling you, you only see what happens. This is not working, this is also not working. Why? Because all its prefixes should have majority element, and this prefix is not does not have majority element. Even if 1 to 1 has majority, but 1 to does not have na. So you should know that what is the condition to make 1 to I dominating. When will it be dominating? The coder dominate on code forces, right? Anyways, seems like he has only made the question. uh, Let me check. Yeah, so who are the contributors, man? Yeah. Okay, no problem. Okay, G. So, guys, for this to happen now, all the prefixes should be good. P1 should be good. P2 should be good. Till Pi should be good. If you make a prefix array to check if the prefix is good or not. Good prefix means good prefix means in that prefix there is a majority element, and also all the suffix should be good, like s of I. If you make a suffix array, this should be good. S of I minus 1 should be good, it should also have a majority element. S of I minus 2 should also be good, till S of 1, everything should be good, everything should be going great in your life. So guys, this was the observation, and this is how we solve this problem. Yeah, the problem is solved now. Why? See, if I come here, the first two elements should be equal. This needs to be the majority element for each prefix if the prefix wants to be declared as dominating. Guys, this is a common sense. First two elements should be equal. 1 comma 1 comma 2. Okay. If you write here, see, if all the elements are 1, then there is no problem. But if you want a different element, the different element can only come after two ones have come. Now, this prefix is dominating, this prefix is dominating. Now, what about this? Let's check what happens. Let's check what happens. This prefix has a majority element, good. This prefix has a majority element, good. Does this prefix has a majority element? Yes. But what about the suffixes? This suffix has a majority element? Yes. Does this suffix? No. So 112 fails. 112 fails to be dominating. But if I write here, so guys, if you do the operation, like if you do the observation, can you see whatever are the first two numbers, they only will be the majority element of the whole array. Not the whole array, like whatever prefix you consider na, from 1 to I. These guys only will be the majority element in all the prefixes and suffixes. There is no other way possible. Furthermore, things will make it clear. So let's take this array now. Let's say this is the index I. You want to see if this is dominating or not. So yeah, this prefix is good. This is good. This is good. Then this is good because one is coming maximum number of times. Can you feel it? Can you feel it? Because the majority element needs to come for more than I by 2 times. So 1 needs to come I by 2 times in all the parts. Only, that's why 1 can only be the majority element. Other element can never become bigger than 1 if 1 is coming in the first place and the second place. Can you feel it? So guys, you can say that, sir, yes sir, all the prefix are having their majority element. I agree with it. All the prefix are having the majority element. Then what's the problem? What about the suffixes? The suffix is also dominating beta G. 1, then 1, then 2. Guys, did you come to know when will this work? All the suffix are dominating. See? In all, sorry, all the suffixes are good, not dominating. Thus, this suffix is good, it has a majority element. 1 is the majority, 1 is the majority. So guys, do you understand when this would fail? If there was 2 here, if there was 1 here and 2 here, it would fail because 1 and 2 here are coming equal times. So guys, if you want the answer to be correct, the first 2 elements should be 1 and the last 2 elements should also be 1. Then only this will work. Let me write it here. P1 to I can be dominating if first 2 and last 2 elements are equal to each other. So guys, see the prefix, or you can say the subarray. Let's denote the subarray by R, or let's say the part. Okay, R of I to J is nothing but a subarray. Okay, so like R of anything is nothing but subarray. So let's say you consider the subarray from 1 to I. Okay, you, the first 2 elements and the last 2 elements are equal to each other. Okay, and these elements will only be the majority element in all prefixes and suffixes if everything goes well. So guys, if you want everything to go well and to declare this 1 to I part as dominating, the first 2 elements you can see needs to be equal to last 2 elements, because if you change it here, this suffix will fail, it will not be good. So this much observation all of you have done. Now guys, the problem is easy. It's all right. For each index I, just create a P array. Okay, P array. P will tell you true if that prefix is good, and it will tell you false if the prefix is not good. Is this good? Yeah, true. Is this good? True. This good? True. This good? True. For this, how will you check? You see the number is what? 1. You know the previous number also 1. In the hash map, you can check the frequency of 1. Na? If the frequency of 1 is strictly greater than I by 2, strictly greater than I by 2, 1, 1, yeah. If its frequency is strictly greater than I by 2 and P of I minus 1 is also true. Basically, if the previous prefix also had a majority element and all the in the past are also having majority element, and this current element is also a majority element, then this also becomes true. So P array, I think you guys can easily fill up, right? So guys, whenever you are at index I, you can just check P of I now. If P of I is equal to true, it means all prefixes of size less than equal to I are good. Now the only thing you need to check is the suffixes. This is the hard part. But at least we can now focus on the easy part for now. Guys, what is the easy part? Well, you just make this. A prefix is good means if it has a majority element in it. The plus the previous prefix was also good, plus the previous prefix is also good till P of 1. Everything should be good, right? So if P of I equal to true means there is an element in 1 to I which has frequency greater than I plus 2, plus all the previous P's are also true. This needs to happen to make sure that Pi is true means every prefix till from 1 to I is having a majority element. It is good. तो जब पी आई इक्वल टू ट्रू होगा तो आपको गारंटी होगा, अगर बीच में एक भी बार फॉल्स आया ना तो नहीं चलेगा. इफ इट कम्स फॉर फॉल्स इवन वन टाइम इट विल नॉट वर्क. If this was 2, what would have happened? 2 coming 2 times, this coming to the maximum frequency is 2. Is that greater than 4 by 2? Here the length was 4, na? No. This would become false. Now, even if this is the majority element, it will not work. If it is not majority element, yeah, see, what is now? Hash map of 1. This is of size 5, right? Is it strictly greater than 5 by 2? You will say, yes, sir. It is 1 is coming 3 times. So, will I write true? No. You also need to check the previous P. Previous P was false. So, I will have to write false, even if its frequency is good. This prefix is good, but what about the other prefixes? We want all the previous also to be true, right? The previous prefix should be true, which indicates all the previous were also true, and the current element should have the frequency greater than I by 2. So this is very easy to check, right? If hash map of B of I is strictly greater than I by 2 and P of I minus 1 is equal to true, in that case P of I is equal to true. Okay, that's it. Now guys, how to check all the suffixes? See, the problem will only be solved 1 to I is dominating if P of I is equal to true and min of suffix array we will also make. Min of S of 1 to I is strictly greater than 0. And the problem is solved. Done, done, done. Now you will be saying, sir, what is this suffix array, sir? Don't cry, beta. Ji, I am here for you. So what I am saying now that, see, now you never ask me, sir, if the prefix is good or not. I taught you that thing, okay? We assume that now O of n pre-calculation you have done for prefix array. In O of one time you know all the things, okay? You want to find the answer for index I. Is everything from 1 to I dominating or not? So you will first check P of I, right? Yes, sir, it is true. Good. Is it true? Yes, sir. Now what about the suffixes? See, this will be the suffix. This will be the suffix. This will be the suffix. So guys, you can make a suffix array na. S array. So suffix array will tell you how many times 1 is coming. See, 1 is coming here 1 time. So here you will write 1. 1 is coming here, like 1 here 2 times. Now whenever any other element comes na, you do a minus 1 operation. So a new element is coming na. So 2 minus 1, 1. Then again 1 is coming, so 1 plus 1, 2. Then again 1 is coming, 2. So guys, in this suffix array na, what is it telling you is that 1, 2, 3, 4, 5, I equal to 5. Okay. So if S of I is positive, it means that there is a majority element in it. Why guys? You can like use common sense here. First of all, you decide which will be the majority element everywhere. 1 will be the majority element. So whenever a 1 comes, I do a plus 1 operation here. Right, 2. But guys, when 2 came, why I did minus 1 operation? Did this explains This explains that the difference of 1 and 2 is 1. This explains that in this part, 1 is coming 2 times, 2 is coming 1 time. What is the difference of 2 minus 1? 1. If this difference becomes 0, then you are screwed. Why? If there were 2 times 2's coming here, na, there would be a 0 in this array. So if there it was like 2 comma 2 comma 1 comma 1, initially the suffix array would be what? 1, then 2, right? But here it would become 1 and then 0. 0 means what? Majority element has disappeared. Neither 1 is majority in this suffix, neither 2 is majority, neither 1 is majority. So if this suffix array has an element which is negative or 0, it means all the suffixes are not good, beta G. So that's it. Just make the suffix array at each index. When you see this guy, what will you do? Whenever the one is coming, you just add a one here. Whenever one is coming, add a one here. Whenever one is not there, you do minus one. In the previous two minus one, one. Then whenever one comes again, two, and then whenever one come again, three. Okay. So what is the minimum element? Minimum of this you can find using segment tree. Minimum of this range. Minimum. What is the minimum? Minimum of s of 1 to I needs to be greater than 0. What is the minimum? Minimum is 1. It means that the frequency of majority element will at least be in all the suffixes. Majority element will exist. Majority element will not exist if any S array element is 0 or minus 1, minus 2, minus 3 like that. Like if you want, I can show you example also, beta. Let's say this was the case, okay? Okay, so your prefix array would be saying here, okay, yes sir, all fine. Yes sir, all fine. Yes sir, all fine. Yes sir, this is now index I plus 1 is this, okay? Yes sir, this is all fine sir. All going good sir. Now what, lovely people? Now what? Prefix so is good only, na? I think 1, 2, 3, 4, 4 minus 3, all good. But if you make the suffix array, how will it look like? You know that 1 is your majority element. So this is not 1, so minus 1 here. Then 1 comes, whenever 1 comes, you do plus 1, 0. Then 1. Then 1 is not there again, 0. Then 1. Then 2. So guys, this is the suffix array. This is the suffix array. This is s of I plus 1. This is s of I minus 1, I minus 2. Then index 2, then index 1. Can you see there are zeros and negative element? If there is a 0, na, it means this part has no majority element, which is true. See, na, this part has no majority element. Here also there is a 0, right? It means this part has no majority element. Yes, 2, 1 has no majority. And if there is a minus 1, 0 negative number, then also you can say that, sir, yes, there is a majority, but there is not a majority of 1. We want 1 as the majority. So you better be careful. And the carefulness is that the maximum in this suffix array na, should be strictly greater than 0. But guys, now the doubt will come in your mind that, sir, I have a doubt, sir. Yes. Sir, let's say you have the suffix array created for till index I, okay? You at index I, if only you consider till index I, then 1 was here, right? 1 was there, then it was 2, then it was 1, then it was 2, and it was 3. But sir, when I transition from I to I plus 1, I know this is 2, so I will write minus 1 here. But I will have to do minus 1 to all these suffixes now. Because if this guy is now minus 1, so this minus 1 will be added to all these suffixes now when you calculate these suffix sums like this. So yes, you are right. When you come at index I plus 1, if this number is not equal to 1, not equal to your majority element, the first two elements is not equal to that, you write I plus 1 as minus 1, and the previous elements from range 1 to I minus 1, you will decrement them by minus 1. So guys, keep the last element as minus 1 and decrement all other elements by minus 1. So 1 minus 1, 0, 2 minus 1, 1, 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, which is correct. See, for this 2, this 1, 2, 0, see, it's correct. So this suffix array you can make. by using lazy propagation on segment tree. Lazy propagation segment tree. जब भी तुम इंडेक्स आई पर हो and you know that ith element is not equal to the majority element which we know should be there, you will write s of I as minus 1, and also you will run a for loop. If you are a noob or a beginner, run a for loop from 1 till I minus 1 and do s of I equal to s of I minus 1. This you can do in O of log time using lazy propagation segment tree. You can go and search on Google or check out my course for that. I'll try to attach some links for that. So you will update all the elements of this range. You will do minus 1 to them in log n time only, not in O of n time. And that's it, guys. Then you will do the minimum query of the segment tree and it will tell you the minimum element in this range. If the minimum element is greater than 0, like here it is not greater than 0, then but if it is greater than 0 and pi equal to true, then prefix I is dominating, guys. Ha ha ha. So now the only issue is that at index I you need to check all the suffix of the array 1 to I to declare 1 to I is dominating. R of 1 to I can be dominating if first two elements and last two elements are equal to each other. These elements will only be the majority element in all the prefix suffix. If everything goes well, R 1 to I gets declared as dominating. Make a simple suffix array, guys. When you are index I, S of I is nothing but the prefix frequency sum of majority element in I to I to these things you know, right? I to I minus 1, 1 to I. If min of this is greater than 0, it means all the suffixes are good in 1 to I. And if prefix of I is true, plus P of I is equal to Ram Ram. If P of I equal to true, then 1 to I is declared as dominating. S can be used, maintained using lazy propagation segment tree, odd query plus min query. Ram Ram. Really love you all. I love coding, guys. Ram Ram.